Today we'll be looking at the perimeter and area of irregular shapes. There are several different concepts all within this one lesson. So special attention and focus need to be maintained throughout the lesson. Today's lesson is a bit challenging, I think, because we're going to talk about several different concepts of perimeter and area. But as I always suggest to you, if you take one step at a time and focus on each of the different concepts, the work is actually not as difficult as you think. We're going to begin with perimeter. And we know that for a perimeter, we must count all of the outside edges. The perimeter is the outermost part of a figure. So beginning at the top, we see 2 inches. And we'll add the 4 inches on the left side, the 6 inches at the bottom. The right-hand side has 3 inches. Then we see a horizontal 4 inches, a very small 1 inch vertical, and then we're to the top. So adding these numbers together, first I'll add 2 and 4 is 6, 6 and 3 is 9, and 4 and 1 is 5. Oh, I see some things that work together pretty nicely. I will put 6 and 5 together for 11, and then I can add 9, and I see that my numbers are now compatible. So the perimeter for this figure is 20 inches. We're going to stay with the concept of perimeter for this figure. We've already established that the perimeter is 20 inches. But let's look at this in a different way. Now I'm going to go ahead and square up this figure. So I've made this imaginary line across this figure. And now let's look closely at this section. Here we have 2 inches and 4 inches. And we see this bottom section is also 2 and 4 inches. So for our perimeter, we could say that the top and the bottom are both 6 inches. So that would be a 6 plus 6. And what I wanted you to notice is that the 2 inches at the top, the 2 horizontals, equal the bottom horizontal. Now let's check and see if that is also true for our verticals. So we see that in the verticals, we have this little 1 inch vertical towards the left-hand side. And we have a 3 inch vertical on the right-hand side. 1 and 3 is 4. And we can see on the far left side, we have 4 inches. So our left-hand side can be plus 4, and then the verticals of the small 1 inch, 3 inches, also equals 4 inches. So now we have our perimeter with fewer numbers to worry about, and we have 6 plus 6 is 12, and 4 plus 4 is 8. And once again, finding our perimeter in this alternative method gives us the answer of 20 inches for the perimeter. Let's continue with the concept of perimeter. We know for this irregular shape that the perimeter is 20 inches. The entire outside edge equals 20 inches. But what we don't know is the bottom dimension. You can see there's a question mark there. We're using a problem that we know the answer, just so that we can work through and understand how to find that answer. So next, one way to find out that missing dimension would be to add the sides that we do know. So our 4 inches, 2 inches, and 1 inch would equal 7 inches. And then we have a 4 and 3, and that would be 7 inches also. So 7 plus 7 is 14. We know that our perimeter is 20 inches. So this side must be 20 minus 14. And that would give us a missing side of 6 inches. And that does make sense because our other sides, the 4, the 2 inches, 1 inch, 4, 3, and now 6, that would equal our perimeter of 20 inches. Continuing with the same idea of the missing side, another easy way to find that missing side length would be to look at the known. At the top horizontal, we have 2 inches, and the other horizontal is 4 inches. When you add together the 2 inches and the 4 inches, you again find 6 inches. The total length of this bottom side is 6 inches. Now let's move to the concept of area. We know with area, we're creating square units. And when we think of those like arrays, in a similar way to arrays, the idea is pretty easy. On this irregular figure, I've color-coded it. I've divided this area into 2 parts to make it easier to find the total area of this irregular shape. So let's begin. On the pink section, the pink rectangle, we see that there are 4 inches on the left-hand side. So we divide our rectangle into 4 parts horizontally. There are 2 inches at the top. So this section must be divided into 2 parts. So our area, following the formula of length times width, we would have 2 times 4, or the area for the pink shape would be 8 square inches. And we can go ahead and check that. We can count 1, 2, 3, 4, 5, 6, 7, 8. There are square inches, 8 square inches in the pink section. Our next section, the very pretty blue, seafoam blue, we can see on the right-hand side, there are 3 inches. And we divide that section into 3. The top number is 4 inches. So now vertically, we divide that into 4 units per. So the area of the seafoam blue or green would be length times width, 4 times 3, and that area would equal 12 square inches. But we need to know the total. So first, let's check and make sure that we have a correct 12 square inches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We must add together the pink section to the seafoam blue-green section. So our area now equals 8 square units plus 12 square units, the area would be 20 square inches for the entire irregular figure. Let's double check with our counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yes, it is correct. The area is 20 square inches. For our next example, we'll again start with perimeter. And we'll start at the top with 3 meters. And then on the left-hand side, 6 meters. The bottom is 5 meters. The right side, we have 3 meters. And then the small section of 2, and then again a vertical of 3. We must add these numbers together because it's the entire outside edge. So 3 plus 6 is 9, 5 plus 3 is 8, and 2 plus 3 is 5. The perimeter equals 9 plus 13. The perimeter equals 22 meters. We added all of the outside edges. The next question concerning perimeter is a missing side length. This figure we know equals 22 meters. The perimeter is 22 meters. We can see that there are 17 meters represented already, and we need to know what that missing length would be. So we can take 22, which is the total perimeter, minus the 17 meters that are shown, and there will be 5 meters. The bottom measurement is 5 meters, and that will give us the entire perimeter. Another way that we could look at our perimeter, if we didn't know, we can square up this area, and then let's see if we have 22 when we add together the sides. So the left side is 6, and the right side will also be 6. The top would be 5 meters, and the bottom would be 5 meters. When we add our numbers together, we see that there are 12 plus 10. The perimeter, again, equals 22 meters. When we don't have complete sections, if you'll notice, the blue section is 3 meters. The green section is 2 meters. Adding the 3 and 2, that is a total of 5. We can find the perimeter of a figure in several different ways. You've noticed that we can add all of the different lengths from each part of the irregular shape, or we can also square up the corners and find the perimeter in that way. Now let's turn our attention to area. I've changed the color on this figure so that we can more easily see the square units that we're working with. So on our first yellow rectangle, we see on the left side 6 meters. So the figure must be divided into 6 sections horizontally. At the top, we see there are 3 meters. So we divide the section now into 3s. There are 3 sections, 3 columns. The area for the yellow rectangle, if we follow the formula, length times width, will be 3 times 6. The area of the yellow rectangle is 18 square meters. Next, let's evaluate the green rectangle. You can see on the right-hand side, there are 3 meters. And at the top, the green section is 2 meters. So following again, our formula for finding the area of a rectangle or square, length times width. So we have 2 meters times 3 meters. The area equals 6 square meters. But we need to know the area for the entire irregular shape. So we must look at the 18 square meters for the yellow rectangle and the 6 square meters for the green rectangle. The area equals 18 plus 6. The area is 24 square meters. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We are correct. The area is 24 square meters. Now we have a very odd irregular shape. The perimeter you know to add the outside edges. I believe you'll find that this has a perimeter of 20 meters. But let's turn our focus to area. I'm going to divide this into 3 different rectangles. And actually the first one, we'll look at that top small rectangle, and it's a special rectangle. It appears to be a square. We have 1 meter times 1 meter. So the area for that top section is 1 square meter. Now let's look at the next section. I see 2 meters on the horizontal edge, and then this would be 1 meter along the left. The area equals length times width. So the area for that rectangle is 2 square meters. Moving on to the third rectangle, I see a length of 3 along this bottom edge and a width of 4. So the area equals 3 times 4. The area equals 12 square meters. Now we must add each of the rectangles together to find the total. So the area equals 1 plus 2 plus 12. The area equals 15 square meters. We have 1 on the top, and then we're dividing this into 2 sections. Now we have our 3 sections, and let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 square meters in this irregular shape. Let's try dividing this irregular figure in another way. This time, let's make a long, thin rectangle. So the area for this rectangle, we see the length is 1 and the width is 2. So the area of that section is 2 square meters. Now, let's make another rectangle in this direction. You can see that the length is 4. I'm going to just go ahead and fill that in. The length is 4, and the width is 1. So 4 times 1, the area of that section is 4 square meters. We have our final section that is 3 meters by 3 meters. So the area equals 3 times 3, length times width. The area is 9 square meters. Our next job is to add all of these rectangles together to see the total amount of square meters in this irregular shape. The area equals 2 plus 4 plus 9. The area equals 15 square meters. Let's divide the rectangles up and double check our work. So we have 2 units on our first rectangle, and because this is 1 meter wide, this next rectangle is divided into 4 parts. And I know that these are not perfect square units, but we will have to pretend for this part. The bottom rectangle is 3 meters in each of the directions, horizontally and vertically. Now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The entire area of this irregular figure is 15 square meters. One final example with this same shape. Our first rectangle will divide in this direction. So you see the area is length times width. The area equals 12 square meters. For our next rectangle, it's pretty small. We have 1 meter and 1 meter. So the area equals 1 times 1. The area equals 1 square meter. For the final rectangle, we have 2 meters and 1 meter. Following our length times width formula, we have the area equals 1 meter times 2 meters. The area equals 2 square meters. Let's check. We have one area of 12, another of 1, and the final section with 2 square meters. The area equals 12 plus 1 plus 2. The area equals 15 square meters. So what I'm hoping that you noticed, regardless how we divided this irregular shape, the square meters were always the same. So let's divide up just to make sure that our work is good. We have 2 meters here and we'll just divide. The next section that has blue was 1 meter by 1 meter. On the final rectangle, we have 3 sections and 4 sections horizontally. So we're ready to count our square meters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 square meters in this irregular shape. Again, it does not matter how you divide the shape, the square meters will always be the same. That concludes today's lesson. As always, my suggestion is to focus on what question is being asked and then pursue a course that will answer that question. Work slowly, work carefully, and with time and practice, you will achieve success in all of these concepts.